Good evening, everyone. In today's class, we are going to discuss about counters again, sequential logic circuits. Okay, so in our last class, we discussed about what sequential logic circuits continuation, that is registers. Okay, what is meant by register? It is a device which is used to store the binary information. And what it contains, how the shift register is made with. Shift register is manufactured with flip-flops. How many number of flip-flops are there in shift register? That depends upon the storing of binary information. Okay, and what is the capacity of shift register means depends upon number of flip-flops, the capacity of shift register will be increased. Okay, if the shift register is designed to store n number of bits, n number of flip-flops are used. If it is designed to store only one bit, one flip-flop is enough. So that the shift registers are manufactured based on the number of bits. So based on the number of bits, the flip-flops must be used. Okay. So this is about what register. And what is the need of register? What we discussed in last class. So the registers are used to store the binary information as well as shift the binary information. Okay, while the purpose of shifting the data may be shifted either to the right side or to the left side. And while coming to the storing, the registers are used to store the data temporarily, not in a permanent manner. Okay, so these are used to store the data in temporary manner, and these registers are used to shift the data either in left side or to the right side. And while coming to the types of registers based on the movement of data, again the registers are of two types: shift left register, shift right register. Okay, in shift left register, the data must be moved from right to left. In shift right register, the data must be moved from right to left. And while coming to the receiving of the input and sending of the input, in which fashion the register will receive the data and in which fashion it will send the data, based on that the registers are again classified into two types: serial as well as parallel. So based on the serial and parallel, again the registers are classified into four types: CISO, that means serial in serial out; SIPO, serial in parallel out; PIPO, parallel in parallel out; PISO, parallel in serial out. Means they are abbreviated like that. So among all these, serial in serial outs will take much more time, gives accuracy. Why? Because in serial out register, the data must be received bit by bit. For receiving every bit, one clock pulse is required, and also the data must be sent out bit by bit only. But in serial in parallel out, it receives the data in serial fashion, but it will send the data in parallel fashion. And while coming to the parallel in parallel out, it becomes very speed. All the bits entered into the register at the same time, and all the bits leave the register at the same time, so that it will require only two clock pulses. So how many number of clock pulses are required? Only two clock pulses are required. One is used for to receiving the data and one is used for to sending the data. And in our last class, we are already discussed about shift left register and shift right register, and both are 4-bit registers. Okay, and in both shift left and shift right, we are working with data flip-flops or delay flip-flops. So what is the main reason to use D flip-flop in shift registers? Already we discussed. In D flip-flop, whatever the input we are applied, that only simply pass it to the output. Means output follows the input. Simply the data flip-flop will transfer the data from one place to another place. So that's why it is used in the shift registers. The meaning of shift means shifting the data. So D flip-flop will shift the data. Whatever the input we apply, that is equal to output. For example, if D is equal to 1, we are getting output Q is equal to 1. If I applied D is equal to 0, we are getting Q also is equal to 0. And also we are seeing the serial in serial out register, serial in parallel out, parallel in serial out, and also parallel in parallel out. And more one register also we completed in our last class, so that is bidirectional shift register. Okay, so what is the main advantage of bidirectional shift register is it is a register having the capability of shifting the data in both directions. Only one register having the capacity of shifting the data in both directions. Okay, so no two registers are used. If bidirectional register is there, it is able to shift the data from left to right and also having the capacity of moving the data from right to left. Simply it shifts the data towards left, also towards right. For that purpose, in addition to the D flip-flops in the construction, it having two AND gates and one OR gate. Each and every flip-flop receive the inputs through the two AND gates and one OR gate. Okay, so in addition to the flip-flops, it also contain two AND gates, one OR gate for the sake of bidirectional shifting. So cause of it requires two AND gates, one OR gate, one flip-flop. For each bit, the circuit becomes complex. But what is the advantage? It shifts both directions. It will shift the data both directions. If we are having bidirectional shift register in our hands, then no need of shift left and shift left right registers individually. But while compared to the shift left and shift right registers, cost of the bidirectional shift register is somewhat high. Why? Because here for each and every bit it requires one flip-flop and two AND gates and also one OR gate. And how it will shift the data to the left side and how it will shift the data to the right side means it will shift the data to the left and right depends upon the R by L bar signal. So if we apply R is equal to 1, the data must be moved to the right side. If we apply low level signal across the R, then the data must be moved towards the left side. So in this way, the data must be transferred from left to right and right to left. So these are the different topics we are discussed in our last class. Okay. So now in today's class, we are moving with our common applications of shift registers. Already I told you, the register is used to store the binary information as well as it is used to shift the information. Okay. See here first application shift register is used to store the information means what? Storing device is called what? Memory. So where we are storing the data, simply the name of the device is called what? Memory. So here where the registers are used, the registers are used in memory, simply like our papers in our book. So papers are used to store the information. Okay, like that registers are used in the memories to store the binary information. Okay, and see next, these are also used in delay line. How the registers are used? Delay line. Why? Because simply if the data flip-flop is there, whatever the input we applied across the D, it simply passed through the output. Okay. So now here you see CISO shift register may be used to introduce the time delay, serial in, serial out. Shift register may be used to introduce the time delay. So how much time delay we introduced is delta T is equal to N in, okay, where N is number of stages, FC is clock pulse. Okay, and see here while coming to the more one application, serial to parallel converter. So see here I would like to draw the symbol of CISO and CISO once. So see serial in, serial out means the data must be entered serial and this is serial in, serial. But serial in, parallel out means the data must be entered serially and the data must be. So these are the two logic symbols of serial in, serial out and serial in, parallel out. Okay. So now see the serial to parallel converter, the data in serial form can be converted into parallel form by using SIPO shift register. Okay. So these are the wide variety of applications where we are using our registers. And while coming to the next application, parallel to serial converter. So these parallel to serial converters are used in PISO shift, either it may be microprocessor or microcontroller or memory, like that. Okay, so this is about what? Our registers. How many types of registers are there? Shift left is there, shift right register is there, and also bidirectional register is there. Okay, and what is the main thing? It is used to store the binary information, and also it is used to transfer the data either towards the left side or towards the right side. Okay, and while coming to the next topic, counters. Okay, after registers we are discussed about what? Counters. Okay, what is meant by counter? It is a device which is used to count the number of bits. What is meant by counter? It is a device which is used to count the number of bits. In register, simply it store the bits, but counter also will count the bits. Okay, counter will count the number of bits. For example, if I would like to apply 50 bits, these 50 bits are counted by our counter. Okay, and here these counters are constructed by modifying the serial in serial out shift register. So how the counters are manufactured? Okay, so how the counters are manufactured? By modifying, by adding some gates to the serial in serial out shift registers, the counters will be manufactured. Okay, and see here, while coming to the counters, the first type of counters are ring counters. Okay, first kind of counters are ring counters. Ring counters are there, ripple counters are there, synchronous counters are there, asynchronous counters are there. But now we are discussed about what? Ring counter. So here there are two types of ring counters are there. How many types of ring counters are there? Two types of ring counters are there. So what is the name of the first one? The first one name is called what? Basic ring counter. What is the name of the first one? Basic ring counter. Technical issue is there. Okay, so ring counters are basically classified into two types. What are the two types? Basic ring counter and Johnson ring counter. Basic ring counter and Johnson ring counter. Okay, and how the ring counters are manufactured? By modifying the serial in serial out shift register, the ring counters can be manufactured. And see here, the basic ring counters can be obtained from serial in serial out shift registers by connecting the Q output of last flip-flop to the D input of first flip-flop. So here the ring counters are classified into two types now, basic ring counters and Johnson ring counters. And here both ring counters are made with by taking simple modifications on the serial in serial out shift register. Okay, and which modifications we are doing to the serial in serial out shift registers to make it basic ring counter? Simply the output of the last stage flip flop is connected. For example, if this is the last stage, the output of this last stage is given to the input of the first stage, first, second, third, fourth. So like this, the output of last stage is connected to the input of first stage. Okay, so this is about what? A ring counter. And see here, and while coming to the Johnson counter, it can be obtained from a serial in serial out shift register by connecting the Q output of the last flip flop to the D input of the first flip flop. Okay, means simply both are First one is made with Q, second one is by connecting Q bar. Is it clear? So these are the two type of ring counters. How many types of ring counters are there? Two types of ring counters are there. One is called basic ring counter. The other one is called Johnson ring counter. So in basic ring counter can be obtained by connecting the output of last stage to the input of first stage. And the Johnson counter can be obtained by connecting the output of last stage Q bar to the D input. So this is about what? Basic ring counters. Okay. And next application is arithmetic and logic unit. Okay, all these are the applications of registers. So the shift registers are also used in arithmetic and logic circuits to perform arithmetic and logical operations. So where we are using shift registers are also used in ALU circuits, arithmetic and logic circuits. Why we are using these in ALU circuits? To perform arithmetical operations and logical operations. And which kind of arithmetical operations it will do? Like multiplication, division. Okay, and which kind of logical operations? Complementation of binary numbers. With the help of our T flip-flop, we are getting complement. If we are applying 0, we will get 1. If we are getting 1, we will get 0. Okay. And next topic is count. Okay. Next topic is counter. So what is meant by counter? It is a register which has the ability of counting the number of clock pulses that have arrived at its clock inputs. Already I told you in single word, counter is a device which is used to count the number of pulses. In one word answer. Okay, what is meant by counter? It is a device which is used to count the number of pulses. Simple answer. And how the counter is manufactured? With help of registers. So that's why it is also called, it is a register which is used to count the number of pulses arrived at its input. Is it clear? It is a register which is used to count the number of pulses arrived at its input. So this is the definition of counter. Okay. And see here how the counters are manufactured. By flip-flops are connected together to perform the counting operation. So which kind of flip-flops are counter? JK flip-flops or D flip-flops. Okay, depends upon the requirement or type of the counter. Sometimes we are moving with JK flip-flop and sometimes we are moving with the D flip-flops. Okay, and see, in gates in a counter are connected to produce prescribed sequence of binary states in the register. Basically, the counters are designed with registers. Internally, it consisting of flip-flops. Sometimes, in addition to the flip-flops, they also having gates to produce some prescribed sequence. Okay, and n number of flip-flops may count the pulses up to 2 to the power of n. So, what is the relation between the counting here? In register, the number of bits stored is equal to the number of flip-flops. Okay, listen carefully. In register, n number of, if we want to store n number of bits, it requires n number of flip-flops. But here in counters, if n number of flip-flops may count the pulses up to 2 to the power of n. N number of flip-flops count the pulses up to 2 to the power of n. Okay, and see here, already I told you now, n number of pulses. I would like to give one example. For example, here I would like to take 2 to the power of 2, means here n is equal to 2 means how many number of inputs it would like to counting? 4 pulses. So to count 4 pulses, how many number of flip-flops required here? 2. So in this way, if n is equal to 3, then there is a possibility of counting 8 clock pulses. If n is equal to 4 I required, then the circuit is able to count 16 pulses. Okay, so 2 to the power of n is equal to what? Number of clock pulses to be counted. Here n is equal to what? Number of flip-flops are used in the designing of our circuits. Okay, is it clear? And see here, next one is modulus of counter. Okay, this is very important. Every question paper, either maybe the competitive exam question paper, or it may be your exam, mid one, mid two, final exam paper, each and every question paper having that modulus of the counter. So first of all, I would like to explain what is meant by modulus, that are modulus. So here modulus means how many number of clock pulses is counted by the counter is called what? Modulus of that particular counted. How many number of states or how many number of clock pulses are counted by the counter. Any clock pulses, how many number of clock pulses we are counting here is called what? Modulus of that counter. So simply in your examination, if you are getting the question, define modulus of the counter means what? Modulus of the counter is abbreviated as mod, and while coming to the definition, the capacity of one counter to count the number of states. How many number of states are counted by the number that particular counter is called what? Modulus of that counter. If n number of flip-flops may count pulses up to 2 to the power of n, here if n is equal to 3 indicate flip-flops. If 2 to the power of 3 is equal to 8 means that is considered as mod 8. Here see in example mod 3, mod 5, mod 16, mod 10 is there. So in first one, mod 3 means the circuit is able to count the clock pulses 3. So for 3 clock pulses, how many number of flip-flops is required? 4. Why? Because 2 to the power of n is greater than or is equal to 4. And 2 for mod 5. So mod 5 indicate modulus 5 counter. Modulus 5 means what? The circuit is able to count 5 clock pulses. So to count 5 clock pulses, it requires what? How many number of clock pulses? Flip-flops 3. If it requires 2, it only able to count 4 states. But 2 to the power of 3 means now the circuit is able to count 5 states. So next one is mod 16. Now the circuit is able to count 16 states. Now the circuit is able to count 16 states. So that it becomes 2 to the power of 4 is equal to 16. 2 to the power of 4. So here how many number of flip-flops are used in mod 16? 4 flip-flops. How many number of states we are getting here? 16 states. Okay. And the last one is mod 10. Okay. See here. In mod 10, how many number of states we are counting? 10. And how many number of flip-flops we are using? Same, 2 to the power of 4. Why? Because if we are requiring 3 flip-flops, that is equal to 8 only. But 10 is more than 8, so that here we are requiring 4 flip-flops. Okay. So finally, what is meant by modulus of the counter? The ability of the counter to count how many number of states is called what? Modulus of the counter. And it is abbreviated as mod. If mod 3 means 3 states are there here. Mod 5 means the counter is able to count 5 states. Mod 16 means the counter is able to count 16 states. And mod 10 means counter is able to 10 states. Okay. And how many number of flip-flops are required? Depends upon 2 to the power of n is equal to mod 16 means 16. So by replacing n is equal to 4, we are getting 16. So that mod 16 counter will requires 4 flip-flops. Okay. And see here, now we are discussed about types of counters. See how many types of counters are there basically? According to the application of clock pulse. According to the application of clock pulse, the counters are classified into 2 types. How many types are there? 2 types. One is asynchronous counter. The other one is synchronous counter. Okay. 2 types of basic counters are there. First one is asynchronous. These asynchronous counters is also called ripple counters. Okay. Asynchronous counters is also called ripple counters. And the next one is called synchronous counter. See here the differences between the asynchronous and synchronous counters is there. Before going to that, first I would like to give brief introduction about asynchronous and synchronous. So see the diagram. So see here first one is asynchronous and second one is synchronous. So what is the difference between these two means? Observe here first diagram, asynchronous diagram. Clock pulse is applied to only the first stage flip-flop. Clock pulse is applied to external clock pulse only first stage, and the remaining flip-flops getting the clock pulse from the output of previous stage. Okay, the external clock pulse is applied to only first clock pulse. The remaining stages will getting the clock pulse from the previous stage. Okay, and while coming to the synchronous, clock pulse is applied, same clock pulse is applied to all the flip-flops at the same time. But in first case, only for the first flip-flop the external clock pulse is applied, and for the remaining the output of previous stage acts as the clock pulse for next stage, and the inputs are applied externally. But in synchronous, clock pulse is applied to all the flip-flops is same clock pulse is applied to all the flip-flops at the same time. But here the output of one stage acts as the input of next stage. So this is the main difference between asynchronous and synchronous. So what is the main difference? In asynchronous, all the flip-flops not triggered by the same clock pulse. The external clock pulse is applied to only one flip-flop, and the remaining flip-flops getting the clock pulse from the previous stage. And while coming to the synchronous, okay, the clock pulse must be applied to all the flip-flops. Simply all the flip-flops triggered by the same clock pulse. So this is the main difference between synchronous and asynchronous. Is it clear? So now you see the table. So first flip-flop is clocked by the external clock pulse. Already I told you now. Only the first flip-flop is clocked by the external clock pulse. Next, each successive flip-flop is clocked by the Q output of the previous. While coming to the synchronous, clock input is connected to all of the flip-flops and hence clocked simultaneously. Is it clear? I think already you getting with the help of diagram. So in asynchronous counter, only the first flip-flop is clocked by the external clock pulse, and all other flip-flops are clocked simultaneously with the output of previous stage. And in synchronous counter, the clock input is connected to the all of the flip-flops and hence clocked simultaneously. And see here, asynchronous counter is somewhat slow compared to the synchronous counter. Why? Because to getting the clock pulse, next stage, second stage waits until the first stage response occurring, and the third flip-flop waits for the output of second, fourth wait for the output of, means here more delay is produced because of this waiting. But in synchronous, there is no need of waiting, so the circuit becomes faster. And asynchronous counters simply called serial counters. Bit by bit the bits are counted. But in synchronous counters, all the bits must be entered at the same time and counted. You see here, in a synchronous counter, delay is more, obviously. Why? Because every stage waits for the output of previous stage. Why? Because if receive the output only, then it will be switched. Why? Because output of the previous stage acts as a clock pulse for the next stage. Okay, and in the synchronous counter, the propagation delay is less, obviously. So these are the main differences between asynchronous and synchronous counters. See here, this is one of the main counter that is called asynchronous counter. Okay, which kind of counter? Asynchronous. So the name itself indicates asynchronous counter means what? Only the clock pulse is applied. This clock pulse is applied to the first flip-flop. See here, the pulse is applied to only first flip-flop. And see, the output of first acts as a clock pulse for the second. Okay, in construction, it is designed with JK flip-flops. Okay, asynchronous counters are designed with JK flip-flops. How many number of flip-flops are there? 4 flip-flops. So cause of 4 flip-flops, how many number of states it count? 16 states are counted by this ripple counter. Okay. And see here, the clock pulse, external clock pulse is applied to first flip-flop only, and the output of the first one acts as a clock pulse for the second one, and the output of the second one acts as a clock pulse for the third one, output of third acts as a clock pulse for the fourth one. Okay, and the input must be applied to all the flip-flops at the same time. But even though the input is present, irrespective of clock pulse, it is unable to produce the output. Okay, so that it will produce the delay in the output. Okay, in a synchronous counter, the counters are designed with help of JK flip-flops, and the clock pulse must be came from the output of previous stage, and the input must be applied to all the flip-flops at the same time, same input. Okay, once see the slide, the pulses to be counted are applied to the clock input of the flip-flop 0. The output of each flip-flop is connected to the clock input of next. Okay, and for all stages, JK are tied together to the supply voltage. Means J and K is equal to 1, which acts as a flip-flop. So this condition, see, J and K are connected together. See here once, J and K connected together, J and K connected together, J and K are connected together and given to the 1. That means these are given to the supply voltage, whether it may be 5 volts or it may be 13 volts. Okay, and see, while coming to the instructional principle of operation, each flip-flop will be toggled when its clock input receives. Already I told you, after getting of clock pulse only, flip-flop is in active condition. For example, for getting the output of first one, it will wait for the previous one. Okay, the Q, see here, this is the operation of truth table of our asynchronous counter. So for the first clock pulse, all the flip-flops will be in absent condition, so the output is 0, 0, 0. Next, for the second clock pulse, the output of Q0 is 1 and remaining are 0. And for the second clock pulse, this output will be shifted to the first one, so that getting Q0 is 0 and Q1 is 1. So in this way, the circuit is able to count 15 clock pulses. After 15 clock pulse, again it returns to 0. Why? Because here how many number of flip-flops are used? 4. So what is the capacity of this counter? 16 only. So that it will count 16 pulses only. 16 pulses means from 0 to 15. Okay. What is the capacity of this counter? 4-bit ripple counter? 16. Modulus is 16. So how many number of clock pulses it counts? 16. From where to where? 0 to 15. If we apply the 16th clock pulse, that means 17th clock pulse, the output of all the flip-flops returns to 0. Is it clear? This is the truth table of our counter. So it is very, very easy. Why? Because for remembering, you simply write equivalent binary numbers of decimal. 0, 0, 0, 1, 0, 0, 1, 2, 0, 0, 1, 0, 3, 0, 0. I mean, some people are unable to remember the table, but you know the binary numbers now based on 8421 code. You simply write the equivalent binary numbers of the decimal. Is it clear? Okay. This is the counting sequence diagram. See where the counting started at 0. Where the counting is started at 0. Next 0 0 1 0 1 0 0 0 1 1 0 1 0 0 0 1 0 1 like this until we are getting 1 1 1 means this is the 0 pulse, this is the 15th pulse. The counting returns to 0. Why? Because this counter is able to count only 16 clock pulses, 0 to 15. How many number of clock pulses it count? Only 16 from 0 to 15. Okay. And see, this is a diagram. So how the diagram can be drawn? So first, once you observe the truth table, so in Q0, once we observe what is the output of Q0, 0 1 0 1 0 1 0 1. Every time we are getting 0 1 only. And now you observe the Q1 in truth table, 0 0 1 1 0 0 1 1 0 0 1 1. And here you observe 4 zeros 4 ones 4 zeros 4 ones. First time we are getting 0 1 0 1 in order, and second time 2 zeros 2 ones, third time 4 zeros 4 ones, and last time 8 zeros 8 ones. Now it is very easy enough. First for the Q0 we draw like this, high low high low high low high low, clock pulse timing diagram, very easy. For Q1 2 zeros 2 ones, 2 zeros 2 ones, and for Q3 4 zeros 4 ones, 4 zeros 4 ones. For Q4 8 zeros and 8 ones. Very easy drawing of timing diagram for the counters, but we are getting full marks after drawing the clock pulsar. If we understand the concept only, it becomes easy. If we didn't understand the concept, then it is very difficult. Okay, some people may not understand the concept. See here, Q0 getting 0 1 0 1 0 1 0 only. Already I told you this is there in truth table, 1 0 1 0 1. And next time see here 1 1 0 0 1 1 0 0 1 1 0 0. Q1 4 zeros 4 ones, 4 zeros 4 ones. Last Q1 8 zeros are there, 8 ones are there. It's very simple. Once you understand the concept, means you understand the truth table. From the truth table there is a possibility of drawing the timing diagram. Okay, and see here the counter, what we are discussed in this class is what is meant by counter, and see here the counter is a sequential circuit that count the pulses in binary form. Which pulses counts? Binary pulses. And how many types of counters are there? 2 types. What are the 2 types? One is synchronous, other is asynchronous. In today's class we are discussed about what? Asynchronous counter. So now tell me, what is the main difference between asynchronous counter and synchronous counter? So in asynchronous counter, the clock pulse must be applied to only first one. Okay, first flip flop, and all other flip flops are triggered with help of output from the previous stage. Is it clear? So while coming to the next one, synchronous counter, all the flip flops are triggered simultaneously at the same time. Okay, by the one clock pulse. See here they mention 2 points. In synchronous counter, all the flip flops are triggered by the same clock. But in asynchronous counter, each flip flop is triggered by the output of the previous flip flop. A very important. Remember. See. While coming to the multiple sorry, each and every competitive exam will getting the questions, multiple choice question. See here first question, a 4-bit ripple counter counts up to 4-bit ripple counter. What is the counter? 4-bit ripple counter. 4-bit, the name itself indicate counts up to 4-bit. 16. Okay, 16 means 0 to 15. Next, a ripple counter is a asynchronous or synchronous? Asynchronous counter. Okay, which is answer once you check? Asynchronous. Is it clear? It is an asynchronous counter. And see, well, coming to the previously asked questions or important questions, give the differences between synchronous and asynchronous is very, very important. So now tell me, what is the difference between synchronous and asynchronous? While coming to the first difference, in asynchronous counter, the external clock pulse is applied to only first flip-flop, and the other flip-flops getting the clock pulse from the output of previous stage. And in synchronous counter, all the flip-flops must be triggered simultaneously at the same time with the same clock pulse. And while coming to the second difference, the propagation delay of a synchronous counter is more compared to the synchronous counter. And while coming to the fourth one, asynchronous counters cause of high propagation delay become slower, but synchronous counters becomes very fast. So these are the main differences between the synchronous and asynchronous. It may be the 3 marks question or it may be the 5 marks question, depends on the examiner choice, but you prepare whole points. And while coming to the next question, 5 marks question, explain the working of 4-bit ripple counter with its block diagram, state table, or it may be sometimes called truth table and timing diagram. Okay, state table means truth table. So here, if we are having 5 marks, the 5 marks are divided into block diagram carries 2 marks, and state table carries 1 mark, and the time diagram carries 1 mark, and our theory carries 1 mark. So in this way, the evaluator will divide the marks, so that you be careful, draw the block diagram and the truth table and also timing diagram. If you leave one part, even though you write the theory for 4 papers, you are getting simply 1 or 2 marks. So here the 5 marks, if the question having 5 marks, the evaluator divide the marks into block diagram carrying 1.5 to 2 marks. Okay, depends upon the evaluator's examiner's 1.5 to 2, sometimes 1.5. And the truth table carries 1 mark, timing diagram carries 1 mark, and the remaining 0.5 are maybe 1 mark for your theory. Why? Because here all these are important compared to the theory. Theory is evaluated from the diagrams only. If you are drawing the diagram construction, in the construction the theory is there. 4 JK flip-flops are used. Output of each is connected to the clock pulse for the next stage. All the inputs are tied together. J is equal to K is equal to 1. Means what? If you know the diagram, theory is easy. So who know the diagram? Who prepared will know the diagram. So without preparing, we write theory by creating. Okay. So next, while coming to the truth table, it will give the number of states counted by the counter, and based on the truth table, there is a possibility of drawing the timing diagram. Most of the people know the truth table, but they are unable to draw the timing diagram. But if once we understand the truth table, concept of truth table, then the drawing of timing diagrams is very, very easy. Okay, and these are the 5 marks questions: asynchronous counter, synchronous counter difference, or it may be the working of 4-bit counter. And in today's class, we are also discussed about applications of registers, shift register. All these are 5 marks questions. And while coming to the 1 or 3 marks questions, define counter and classify the counters. Okay, define counter, what is the answer? It is a device or it is a register which is used to count the number of pulses. And the next most important question, define modulus of the counter. So modulus of the counter means it is the ability of the counter to count the number of pulses is called modulus. How many number of pulses one counter counts is called modulus. Okay, and it is abbreviated as mod. For example, if mod 16 indicate what? It counts 16 pulses. And here one small question is there. In mod 16 counter, how many number of flip-flops are used? I said 4. How it is 4? So 2 to the power of n is equal to number of states. So here n indicates what? Number of flip-flops. So these are the 3 marks question. Define counter and what are the different kinds of counters, simply classification of counters, asynchronous and synchronous counters, and what is meant by asynchronous counter and what is meant by synchronous counters. These are the main 3 marks questions, and modulus of the counter, very very important questions. Okay, and see, in today's class we have discussed about counters, applications of registers, and types of counters, and the ripple counter construction operation timing diagram is also over. Now I would like to conclude the class. In tomorrow's session we will meet again. Okay.